So, hello guys, I'm Shubham Agrawal, and in this session, we are going to learn about linked lists. Okay, so let me see whether am I audible or not. Yeah, I think I'm visible and audible. Okay, okay. So today we are going to study about linked lists. Okay, so linked lists are the data structure. So they are the linear data structure in which a node is there. Okay, and in which data is present and the link to the next node is there. Okay, so this is the basic about linked list in which we are allocating memory dynamically. Okay, so we have studied array. An array is a static data structure in which its size is fixed. Suppose we have an array of three elements, okay, in which 10, 20, 30 is there. So here the size of this array is fixed. So we have only three elements on, and we can't increase its size because if we increase so because it is static. Okay, but in linked list we can increase the size, so we can have any number of nodes in the linked list. Okay, and okay, so this is the basic of linked list. Okay, so let's see what is today's agenda first. Okay, so first we will see what is linked list, then types of linked list, then node creation in linked list, then dynamic memory allocation. So we have four functions: malloc, calloc, reloc, and free. Okay, for dynamic memory allocation. Then we will see how we can traverse the linked list. Then some basic operation like insertion, deletion, searching, and reversing a linked list. And then we will see some gate questions. Okay, so let's start with what is linked list. So as we have seen earlier that linked list is a linear data structure. So linear means it is a sequential data structure in which one element, one element is there, and after that second element will be there, and after that third element will be there. Okay, so they will be in the sequential form, means a sequential manner. So they will be one after another. Okay, so this is the basic structure of linked list in which so we can define a node of a linked list using a user defined structure named with node. Okay, in which we have one data field in which the data is present. Okay, then we have a struct node type pointer which points to the next node. Okay, so in this example, here we have an integer data 10, and then we have a next node. So next node is pointing to next node. Okay, so let's suppose this node address is 1000, this node address is 2000, and this node address is 3000. Okay, so here data is present, and here information of next pointer is present. Okay, so here next will be 2000, so 2000 will be present here. Okay, here 3000 will be present. Okay, and here if nothing is there, then it will be null. Okay, so yeah, so if a pointer is pointing to null, okay, so null is basically zero. Okay, so its by default value is zero. So if it is null, then it is the end of the list. Okay, so this list contain only three elements: 10, 20, 30. Okay, yeah. So in linked list, the locations there on the node. Okay, so the locations are not continuous. Are not contiguous. Okay, because this is located at 1000 index and this is located at 2000 index. Okay, so in array, if we have integer array, okay, so let's have integer array of size 3. So here if we have an address 100, then the next address would be 104 and next address would be 108. Okay, but in linked list this node address is 1000, it can then it is 2000, so it is not 1004. Okay, it is 2000 because it is dynamically allocated, because the this when we create this node, so we will see how we can create a node in a linked list. So we will use some functions like malloc, calloc, so it can return any address. Okay, that address we will store in the next node. So if we have a memory, suppose this is our main memory. Okay. So in this, if one node is present, okay, then second node can be present here, third node can be present here. So they are pointing. So each node will contain the information for its next node. So it will point. Okay, so it will contain the address. And this address so these address are not contiguous. Okay? So they can be present anywhere in the main memory. Okay? So that's why we have linked pointers here to store the information about the next nodes. Okay. So if I have a node and if know the address of the next node, okay, then I can go to that node. Okay. So if I have a node and if I have an address of the next node, then I can go to that node and I can access its value. And if I have the address of the next node, then it is forming a so it is kind of list. Okay, there is linked with the next pointer. Okay, so that's why it is called linked list. Okay, so we are linking nodes with some pointer. Okay, so this is about the linked list in which all the nodes are linked with the pointers. Okay, to the next node. Okay, so let's see what are the different types of linked lists. So first we will see about singly linked list. Okay, so singly linked list is something like this. Okay, so we have a node, suppose its value is 10, and here it is data, and then we have here the pointer to the next node. Okay, so here suppose it is head. So the pointer which is pointing to the first node of the linked list is called head pointer. Okay, then we have the next node. Okay, then we have next node 30, and then we have null. So null can be denoted by a symbol like something like this. Okay, so it means null. Okay, so it means end of the list. Okay, now this is the singly linked list in which we have a linked list which is so from head node we can go to the next node one by one. Okay, until the null is found. Okay, so in this way we can traverse the linked list in one direction. So we can go from head to the null. Okay, end of the list. But in doubly linked list we have two pointers. Okay, so in this we have data present here. Okay, and then we have a pointer to the next node. Okay, so here we have two pointers. First will be previous and second one is next. Okay, so here next will point to this and previous will point to the previous node. So it will point to this. Okay, so let's suppose it is 20, then we have next, then we have another node here, 30. So here the previous points to the next node. Okay, and then we have the last node null. Okay, so it is pointed here. The last node next will point to null. Okay, and here the head will point to this. Okay, and here the previous will be null because it is a doubly linked list. But uh, so we have to start from head, and since there is no previous node from here because it is the first node, so that's why its previous is null, and then the next of the last node will be null. Okay, so this is the doubly linked list. Then we have circular linked list. So circular linked list is something like this in which we have a linked list. Okay, and the so if this is the last node, okay, so this will not point to null. Instead of it will point to the first node. Okay, so this is the circular linked list in which the last node will point to the first node. Okay, so if it is a head, then the last node next will point to the head. Okay, so this is our circular linked list. Then we have doubly circular linked list in which we have a doubly linked list, and it is so the next node will be connected to the head. Okay, so we have here first node is there, so its next is pointing to the second node, and its previous will point to the first node. Okay, then its next would point to node 3, that is 30, and here it will point to previous node, and then the next will point to, okay, this head node. Okay, so this is head. So here the next will point to the head. Okay, and here the previous will also point to the last node. Okay, so in this previous will point to the last node, and the next of the last node will point to the first node. So this is our doubly circular linked list. Circular circular doubly linked list. Okay. So we have four kind of linked lists. First one is a single linked list, singly linked list, in which we have a list, but it is in only in one direction, so we can go forward, but we can't go backward. Okay. Then we have a doubly linked list in which we can go forward also and we can go backward also. Okay, because of the reverse pointer. Because of the previous pointer. Okay. Yeah. Then we have the circular linked list in which we have the point. So the last node next will point to the first node. Okay, so in this we can traverse in a circular way. So there is no end in the circular list, but we have the starting node and which is pointed by the head node. Okay, then we have circular doubly linked list in which we have a doubly linked list, and the next of the last node will point to first, and the previous of the first node will point to the last node. Okay, so this is about the doubly linked list, circular doubly linked list. Okay. Now let's move on. So how we can create a node in a linked list? Okay, so so this is the way to declare a linked list node. Okay, so a node has two parts. One is data, and then it has the pointer to the next. So it is next, which is pointing to some other node. Okay, so here data we have defined of integer type, so it can contain some integer value. Then we have a next pointer which will point to some next node. Okay, so how will we create this node? So we will use dynamic memory allocation functions in C, which is Malloc. Okay, so it stands for memory allocation. Okay, memory allocation. And it is a function and it returns a void type pointer. So we have to typecast into a word pointer, which is node pointer. So we will write a struct node star to typecast the result of this malloc, and it will dynamically allocate the size that you specified here in the argument. So here we are specifying the size of our struct node. So our struct node size will be so size of this and size of this pointer. Okay, so suppose that it is for 4 byte and it is of 2 byte. Okay, suppose. Okay, so we have 4 plus 2, so it will allocate 6 byte of memory for node 1. Okay, so we have a pointer, so we are storing that allocated memory. So in the this head pointer, so head is pointing to this node, okay, that we have created. Okay, and to access the structure member, so we have to use dot operator if it is a variable. Okay, and we have to use arrow operator if it is a pointer. So we have seen this in when we have studied structure. Okay, so to access the value of this data, we have to use arrow operator here, because here we are defining the pointer. Okay, so it will be something like this: head of data, head arrow data equal to 10. So it will allocate 10, and then we have head of next equal to 100. Sorry, equal to none. Okay, so here it will point to none. Okay, so let me just erase it. Yeah. So it will point to null. So after the execution of this statement, this will be our result in which data we have 100, and the head is pointing to this, and the next is pointing to null. So we have, because we have specified the value here. Okay. So in this way, we can create a node. So there are some other functions for dynamic memory allocation. So let's see them one by one. Okay. So we have 4 library functions available in C. Okay. So first one is so they are defined in the standard lab. Okay, so we have hash include standard lib dot h. Okay, we have this library that we have to include if we want to use this malloc, calloc, free, and reloc functions. Okay, so malloc. So malloc is function means memory allocation. So it will allocate the memory uh, if we specify the size in this in its argument. Okay, and then we have calloc in which we have to specify the number of elements also. So we will see one by one them. And free is used to free the memory. Then we have reloc, which is used to reallocate the memory. So let's see malloc first. Okay, so malloc function, so it stands for memory allocation, and it is used to dynamically create a single large block of memory with the specified size. So here we have to specify the size. Okay, and this memory that is allocated, it will be allocated in the heap section. Okay, so because it is dynamically allocated, hence it will be allocated in the heap section of the program. So we have four sections in our program. Okay, first one is code, then we have data segment, then we have heap, and then we have stack. So in a stack, function calls are present in and their local variables are present, and heap dynamic memory allocated variable will be there. Okay, so dynamically allocated variable will be present in heap area. Okay, so here if we specify the, so suppose I want to allocate memory of 100 integer for 100 integers. Okay, I want to dynamically allocate the value for 100 integers. Okay, so I will specify the size here. So 100 into size of int, which is of 4 byte. So we have 400 byte of memory, and we have to typecast it because the it returns the type void. Okay, so we have to typecast this into the variable that we are using. So here we are using int star. So that's why we have to typecast it. So it will be void. Okay, so it will return void. So we have to typecast it into int star. Okay, yeah. So here in this pointer variable, we have the first base address of this allocated memory. Okay, so it will allocate 100 elements 0, 1, 2 up to 99. Okay, so here PTR will point to first address. Suppose it is 1000, 1004, 1008, and so on. Okay, so here PTR will point to the first address of this memory, that is 1000. Okay, so it will if we have PTR here, so PTR will contain 1000 and it has, so 1000 will be its value. Okay, so this is about the malloc function. Now let's see about calloc function. So calloc function is used to allocate the memory same way the malloc function does, but here the values are initialized with 0, and in the malloc the values are initialized with garbage value. Okay, so here anything can be present here. Okay, here instead of the garbage value will be present. Okay, but if we allocate memory with the help of calloc, so here the memory will be, so here the memory uh, that is allocated will contain 0 as its default value. Okay, then it is in calloc, it is stands for contiguous memory contiguous allocation. Okay, so in this, we have two arguments. In malloc, there was only one argument in which we specified the size. But in calloc, we have to specify the number of entries that we want for that element. Okay, so let's suppose it is 25 and element size that is of int. So it will be of 4 byte. Okay, so here we have to specify something like this. Then it also returns the void type of pointer. So that's why we have to convert int into the specified pointer that we are using. So here we are using float. So that's why we have to typecast it into the float pointer. Okay. Then this Calloc function, we are specifying 25 here, and the size of float is of 4 byte. Okay, and we have 25 here, so 25 into 4. So one second, 25 into 4, that is 100 bytes of memory will be allocated. Okay, and so we have 0 and up to 99, and here PTR will point to here. Okay, and suppose its address is 1000, so PTR value will be 1000. Okay, so in this way we can allocate a dynamic array. Okay, a dynamic memory locations. So we have in this way we can do dynamic memory allocation using Calloc function, in which if we give the number of elements and the element size, then it will allocate a contiguous memory for that, and it will return the pointer to that memory that we typecast, and then we can use that memory. Okay, and by default all the values will be 0 here. Okay, and it will be 0 but in floating point form, so it will be 0 0.0. Okay, 0 0.0. So this is about the Calloc function. Now let's see about Realloc function. So we have a Realloc function okay, which is used to reallocate the memory. Okay, so it is called reallocation. Okay, and in C, if we want to reallocate the memory, then we have to use this function. Okay, so suppose that we have allocated a memory using Calloc. Suppose it is of 100 byte. Okay, and we have typecast it into integer. Okay, and we have stored it in the PTR, but I need more memory, so I need more than 100 bytes. Then I will use the reallocate function. Okay, realloc, I will write realloc, and then I will give the pointer, this pointer here, and I will give the new size. Let's suppose that is 400 byte. Okay, so it will reallocate the memory, and then we can again, it will return the pointer for that. So we can just catch that pointer. Means we can just take the base address of that memory that will be reallocated. Okay, so here 100 is there. Now it will new array of 400 byte will be allocated. Means new memory of 400 byte, and PTR will point to this now. Okay, so in this way reallocation function works. Okay, and this is the syntax for that, in which we had gave the previous pointer and then the new size of the array, new size of the memory location that we want. Okay, so then we have free, which is used to free the dynamically allocated variables. Okay, so if we have allocated 100 bytes here and it is pointed by PTR, then if we write free PTR, then it will just uh, delete this memory. Okay, so it will just unallocate this memory from the, so this memory is allocated and the pointer is PTR. So after this statement, it will deallocate this memory, and this memory will become free. Okay, so this is about the free function, and this is the syntax for this. Okay, yeah. Now let's see how we can traverse a linked list. Okay, so let's suppose we have a linked list 10, then we have 20, then we have 30, and then we have 40, and then null is there. So this linked list contains 4 elements, and this is the head, okay, which is pointing to the first node. Also, we can use type def function to just shorten our name. So each time we declare a node, then we have to write struct node. So we can just type def it add to node. So we don't have to write the struct again. So we have seen this in when we have studied about structure. So we can use type def here, and we can simply use node from now. So if we want to traverse this node, then we will pass it to our traverse function, and first it will first it will declare a temp variable which is of node type, not pointer type. and it will also point to this. Okay. First, we are assigning head to this temp variable. Now we have a while loop in which until temp is not equal to none, we will just print the temp of data, and we will just move to the next element. Okay. So first, temp is not equal to null. So here temp is pointing to this node. So temp is not equal to null, and 10 will be printed. Okay. And after that, we will do temp equal to temp of next. So here temp will be, so temp of next was this. So temp will point to this now. Okay. Again, the while loop will run and we will see temp is not equal to null. So yeah, temp is not equal to null. Again, we will print the value. And again, temp will to the next element because we are doing temp equal to temp of next. Now temp of next will print 30. So the temp will print 30 temp of data. And again, temp will be equal to temp of next. So it will point to this node. Now its value is 14. And now temp will point to null because temp of next is null. Okay. So now temp is equal to null and null is not equal to null. So condition is so here the condition is false because null is equal to null. Okay. So that's why we will break out of this for loop and this will be our result. So in this way, we can traverse our linked list. If we have a if we have a linked list with the head pointer, then we can traverse that linked list something like this. Okay. So this will be our output. That is 10, 20, 30, and 40. Okay. So this is how we can traverse the linked list. And now let's see how we can insert a node in this linked list. Okay. So let's see first insertion at the front. Okay. So here we have a linked list in which 3 elements are there. Okay. And the last element is pointing to null. Now we have to insert a node at the beginning. Okay. So I want to insert a node at this position. Okay. So for that, so we have head here. Okay. And head is pointing to the first node. Okay. And if we want to insert a new node at the beginning with value this, so let's suppose this value is equal to 5. Okay. So first we will create a node. Okay. So we are using here malloc function for that, and we are giving the node as the size. So it will create a node. Okay. And this node will be pointed by temp. Okay. Now in the data part, we are specifying the value. So it is 5. So we are just giving here value 5. Then temp of next is equal to head. So head is pointing to this node. So we will do now temp of next will point to head. Now we are doing head equal to temp. So now head will point to this node. Okay. And then return this head. So now our head is pointing to 5 and we have inserted this value 5 at the beginning of the linked list. So we have 5, 10, 20, 30. Okay. So we have inserted this node at the beginning. So this is the simple algo for doing that. Okay. In which you first create the node, then we assign the value, then we just in the newly created node, we just assign its next to the head, and then we have head equal to that newly assigned node. So in this way, we can insert the value at the beginning of the linked list. Okay. Now let's see how we can insert at the end of the linked list. So let's suppose we have a linked list. Okay. Here, and it contains 3 elements, 30, 20, and 10. And head is pointing to the first element. Okay. Now we want to insert the value 5 at the end of this linked list. Okay. So for that, first we will create a new node, and its value will be the value that is provided. So it will be 5. And the temp of next is pointing to null. And this is assigned to temp. So temp is pointing to this newly created node. Now first we will take a pointer variable p1 which is of node and it will assign to head. So p1 is pointing to this. Now we will see p1 is so we will do this while loop. So to go to the last element, okay. So we will see p is equal to null or not, and p of p1 of next is equal to null or not. So we see that p1 is not equal to null, and p1 next is also not equal to null. Okay, so then we will do p1 equal to p1 of next. Okay, so p1 will point to here. Then again we see p1 is equal to null or not. So it is not. Then we will see p1's next is null or not. So p1's next is also not null. So we will again do p1 equal to p1 next. So it will point to here. Now we will see p1 is equal to null. So it is not equal to null, but p1 next is null. So this condition is false. Hence we will break out of this while loop, and p1 is pointing to this. Okay. Now if p1 is null, then we will simply assign add to 10. But in this case, p1 is not null. So we will do p1 of next equal to 10. So p1 of next is currently pointing to null. Okay. So now we will assign p1 of next to this 10. So this will point to the end of this list. Okay. So 5 will be our last node now. So p1's next is pointing to 10. Okay. And we will just return the head now. Okay. So in this way, we can insert a node at the end of the linked list. Okay. So in this way, we are inserting a node at the end of the linked list. So this is about the insertion algorithm. So we have seen at the end, at the front, and we have seen the algorithm for the at the end. Now let's see if you want to insert at the given position or not. Okay. So yeah, one second. So if you want to insert at a given position, okay, so how can we do that? So for that we have, so one second. Okay. So we have insert, and then we have head, then we have value. So if we want to insert value equal to 4, okay, here. So first let me create full list. Yeah. 20, then we have 30, and it's pointing to null. And want to insert at position. Okay, so let's suppose the position is start with 0. So this is 0 position, this is first position, and this is second position. So I want to insert this value at the second position. So for that we have this algorithm. Okay, so first we will create a new node. So this new node will be this node in which we have the val. So val is 4, so 4 will be there, and its next is pointing to null, and we have temp which is pointing to this node. Okay, now if head is equal to null, so here head is not equal to null, so we will not go to this if condition. Okay, and we have now two pointers. First will be pointing to p1, that is first is p1 which is pointing to the head of the linked list. Then we have pointer p2 which is pointing to null. Okay, so it is pointing to null. Okay, so let's suppose it is pointing to here, so it is null, so it is pointing to null. So we have I equal to 0. Okay, so I is 0, and we are doing p2 equal to p of 1. So first we are comparing I with position. So I is currently 0, and 0 is compared with 2. So 0 is less than 2, hence the y condition will be satisfied. So p2 will point to p1. So p2 will point to p1. Okay, and we will do p1 equal to p1 of next. So p1 we will move p1 by 1 position. So p1 will point to this now. Now we will do I plus plus. So I will increment it by 1. So it will be 1. Now 1 is compared with 2. Now when 1 is compared with 2, so again the condition is false. Then we will do p2 equal to p1. So p2 will again point to p1. So p2 will point here. Then we have P1 equal to P1 of next. So P1 of next is here. So it is P1. Okay. Now, um, so we have done this. So after this, we have to just increment the value of I. So I will be 2. Okay. So I is 2. Now 2 is compared with 2. So 2 is not equal to 2. So 2 is not less than 2. So here the condition will be false and we will break out of the while loop. Okay. Now we will do P2 of next equal to temp. So P2 of next is this. So it will now point to this temp code. And then temp of next equal to P1. So P1 is pointing to this. So temp of next will point to 30 now. Okay. And then we'll just return the head. So here we have inserted an element at second position. So now its position become third, and this is the node at second position. Okay. So we have inserted a node at position 2. Okay. So this is the algorithm for that. Okay. So this is the insertion at the given position. So we have specified 2 and we have inserted this node at the second position. Okay. Now let's see deletion algorithm. So how can we delete a node from the linked list? Okay. So let's suppose we have a linked list in which 3 elements are there. And here the head is pointing to the first node. Then we will see that head is null or not. So if it is a null, then it contains no elements. So that's why we just print underflow and just return from there. Okay. But if it is not null, so yeah, this head is not pointing to none. So we have a node and we have a list here. So we want to delete at the front. So we have to delete the node at the beginning. Okay. So we want to delete this node. So first we will create one pointer variable and this will point to head. So P1 is pointing to this. Now we will just do head equal to head of next. So head will point to this. And then we just simply free this memory free this memory that is allocated. So it will be free. Okay. And we will just return the head. So this is the our new linked list and head is pointing to 20. So we have deleted the element which was present here. So we have deleted the element which was present at the front. And this is the algorithm to do that. So linked list questions are very easy and their algorithms are also very easy. So we just have to follow the instruction carefully and we can just get our result. Okay. And okay, so let's see how can we delete at the from the end of the linked list. Okay, so let's suppose we have a linked list here of 3 elements and we want to delete the last node of this linked list. Okay, so it is pointing to head and then we have 10, 20 and 30. Okay, so here head equal to null. So here head is not equal to null. So that's why we will not print underflow. So here this condition will be false. So if it is true, then we simply return from this delete function because if the list is empty, then we don't have to delete anything from the list. Okay, so we have to first check whether the head is null or not. Okay, and if we are doing some operation on a pointer variable which is null, so if I'm doing something like head of next, then we will get some exception which is null pointer exception. Okay, so we are accessing a memory location which is so we are accessing a element which is null. So we are accessing its member which is null. So it will create a null pointer exception. So we have to be very careful about it because if we don't specify this base conditions, then our program might get some error in between. Okay, and we don't want that. So that's why we have to check for this conditions. Okay. So now let's delete the element from the end of the list. So we have P1 which is pointing to head. Then we have P2 which is currently pointing to null. Okay. Then we are saying P1 of next is not equal to null or not. So P1 of next is not equal to null. So we will just assign P1 to P2. So P2 is again pointing to this, and P1 will point to P1 of next. So P1 will point to here. Now while loop will run again, and we will see P1 of next is null or not. So here it is not equal to null. So again, P2 will be pointing to P1, and P1 will pointing to the third node. Okay, next node please. So yeah. Now we see P1 of next. So P1 of next is not equal to null. So here P1 next is equal to null. So hence this condition will be false, and we will break out of this while loop. Okay. And here we will simply just do P2 of next equal to null. So P2 will simply point to null. P2's next will simply point to null, and free this memory location. Okay. So P1 free P1. So it will just delete this memory location. Okay. And we will just simply return the head. So we have deleted the last node of our linked list. Okay. Which was present here using this algorithm. Okay. So we are so P1 was pointing to this, and we are just writing free of P1. So it will deallocate the memory allocated by this node. Okay. Which is occupied by this node. So this way we can delete the we can delete the node from the end. Okay. Yeah. Okay. So let's see uh, how we can delete the node from the given position. Okay. So we have a node. Okay. So we have a linked list, and we want to delete from a specified position. Okay. So here it is add. Okay. And we want to delete it from the specified position. So let's suppose that pose is equal to 1. Okay. So I want to delete this. So let's suppose that positions are starting from 0. So 0, 1, 2. So I want to delete this node. That is at first position. Okay. So first I will check for the underflow condition. So add is not equal to null. So we will not enter in this while in this if condition. Then we have P1 here. Then we have P2 which is pointing to null. Then we have a variable I equal to 0. Okay. Then we have a while loop in which I is less than position. Okay. So position is 1 and 0 is less than position. Okay. So this condition is true. So we will enter in this while loop, and we will do P2 equal to P1. So P1 will point to this. P2 will point to this, a node which is pointed by P1. Now P1 equal to P1 of next. So P1 will be here. Okay. So it will point to the next node. Okay. Then we will do I plus plus. So I will become 1, and then 1 will be compared with 1. Okay. So 1 is not less than 1. So this we will break out of this while loop. Okay. Now we will do P2's next equal to P1 next. So P2's next is this. So we will now do P2 next equal to P1 next. So P1 next is 30. Okay. So P2's next will point to P1's next. Okay. And we will just free P1. So P1 will be freed, and so this memory will get deallocated. Okay. So we have deleted our node which was at position 1. Okay. So in this way, we can delete a node at a given position. Okay. And at last, we just return the head. Okay. Head is pointing to 10. So 10 will be returned. But now 10's next will point to 30 because we have deleted that 20. Okay. So this is about the deletion. Okay. So let me see if there are any questions in the chat. Okay. Yeah. Okay. So there are no questions. Okay. So let's see how we can search an element in a linked list. So we have a linked list. Okay. 10, 20, 30. And it is pointed by null. So the last node next is pointing to null. Now we want to search an element in this linked list. Then we have to do a linear search. We have to search one by one. Okay. So we will start from add. So we will take a one temporary variable temp, which will point to head, and we will have one while loop in which if temp is not equal to null, okay, then we will enter in this while loop. So temp is not equal to null, we will enter and we will see temp of data equal to val or not. So let's suppose val is 30. Okay, so 10 is not equal to 30. So if we will not enter in this if condition, and we will do temp equal to temp of next. So temp will point to here. So it will point to the next of the previous temp. Okay. Now temp is not equal to null. So yeah, temp is not equal to null. Temp data is equal to val. So 20 is not equal to 30. So we will not enter in this if condition. Now temp equal to temp of next. So temp of next is this. Okay. And now if we see temp is not equal to null, so it is not equal to null, and temp of data, which is 30, 30 is compared with this value. So 30 is equal to 30. So hence we will enter in this if condition and we will print successful search. So we have find our element in it in this linked list. Okay. So we will just return from this procedure now. Okay. We will return from this function. Okay. But if here 40 was present, so 40 is not equal to 30. So then we again temp was again incremented and then will point to this. Then temp is equal to null. So we will break out of this while loop and then we print unsuccessful search because the element is not present in this linked list. Okay. So but in our case it was present. So we will just simply return successful search. Okay. And temp will point to this. So in this way we can traverse the linked list. So here, if the linked list is containing n elements, so in the worst case, we require to search all the n elements, compare all the n elements. So hence the time complexity become order of n. Okay. So here the time complexity is order of n. Okay. So let's see how we can reverse a linked list. So it is very interesting. Okay. So if we have a linked list, so 20, then we have 30, then we have, and I want to reverse this linked list. Okay. So head is pointing to the first node and I want the result something like this. Head should point to 40, then 30, then 20, and 20 should point to null. So I want output something like this. So how we can do that? So for that we have this small algorithm. Okay. So first we have to define two variables that are current and previous. So current will point to the head. Okay. And the previous node will point to null. Okay. Then we will enter in this while loop. Okay. First we will take one next node. Okay. Variable, and in which we will just take the value of the current of next. So it will point to this. So next node will point to this current next. Okay. Then in currents next we will give the previous. So currents next is this. So in this we will, so let's suppose null is there and it is pointed by previous. Okay. So now the current next, okay, which is here, it will point to the previous. So previous is null. So currents next will be pointing to this null. Okay. And now previous is equal to current. So previous will point to this node. Okay. So previous is not pointing to null now. It will point to this node. Okay. And current is equal to current of next. Current is equal to next node. So next node is pointing to this. So hence current will point to this. Okay. So let me just redraw it once again. So yeah, here, and this previous will point to this node 20. So once again, yeah. So it will point to this node. Yeah. Now current is this 30. Now again, and the next node will be current next. So it will be point to 40. The next node will be here. Okay. Then we have current of next equal to previous. So current of next is this. So it will point to the previous. So it will point to here because previous is pointing to this node. Okay. And current is equal to, and previous will equal to current. So previous will now point to this, and current is equal to next node. So current will point to this. Okay. Again, the while loop will run and current is not equal to null. So next node will be point to this null. Okay. And current of next will point to the previous. So it will point to the previous node. Okay. And then previous equal to current. So previous will point to current, and current will equal to the next node. So current will be, so it was here null was there. Okay. So current will point to null. Okay. So now current is equal to null. So we will break out of this while loop and we will do head equal to previous. So head will point to this previous. And now if you see, so we have reversed the linked list because now head is pointing to 40, 40 is pointing to 30, and 30 is pointing to 20, and 20 is pointing to. So we have just reversed this linked list. So if I write something like this, 40 and 40 is pointing 30, and 30 is pointing 20, and 20 is pointing null. Okay, so we have just reversed our linked list. So in this way, we can just reverse the linked list. Okay, so this is the pseudocode for that. Okay, now let's do one gate question. So this question was asked in gate 2017 set 1, in which we have a C code. Okay, here they have used type def struct node, and they have renamed it to node, in which data and next is there. So a node will contain data and next. Then we have a void join. It takes two nodes and it runs one while loop and do something like this. So assuming that m and point to a valid null terminated linked list. So they are valid null terminated linked list. So a linked list, so n can point to something like this, and here it is null terminated. Okay, and m can point to a empty list. Okay, so it is pointing to null. So it is also null terminated and it is valid. So here m can be an empty list. Okay, so we have to see what uh, so which option is satisfied here. Okay, so for that, so let's consider two lists. Okay, so let's take two examples. So n is pointing to so n is this. Okay, and the last element is null, and we have again a list m in which, one second, 50 is there, then we have 60. So it contains two elements, and this and list contains three elements. So we have taken an example to just run this code. Now p is pointing to n, so p will point to this. Okay, now p of next is not equal to null. So yeah, p of next is not equal to null, so we will do p equal to p of next, so p will point to this. Then again, p of next is not equal to null, so p will point to this. Now p of next is equal to null. Okay, because p of next is null, so that's why this we will break out of this while loop and we will do p of next equal to m. So p of next is this, so it will point to m. Okay, so p is there and it is pointing to m. So after the execution of this code, our so list n and list m are appended. So list m is appended after list n. So if we see the option, append list m to the end of the list n for all inputs. So yeah, it is appending the list, but for all inputs, because we have taken this example, and for this example it is working fine. So let's take another example in which we have n and it is pointing to null. Okay, and we have m which is pointing to node, and it is a single node linked list. Okay. Now, if we do, if we run this function, so node p equal to null. So node p is equal to n, and n is pointing to null, so it will point to p. And when we enter in this while loop, p of next will be compared, and p of next is null. Okay, so p is null, and we are doing p of next, so it will raise some null pointer exception. Okay, so for some imports, so in this import, this code is giving null pointer exception. Okay, so we are accessing the null here, accessing a member of null. Okay, so here we will get null pointer exception. So for some inputs, it is giving the correct output, but for some input, it is giving null pointer. Okay, the correct option should be either cause a null pointer dereference or append list m to the end of the list m. So the correct answer is B. This is true, but for some inputs. Okay, and this is also true for some same inputs. This is totally wrong. Okay, so the correct option is B. Okay, so this is the question that was asked in GATE 2017 set 1. So this was for this lecture. So we have studied linked list in this lecture. So yeah. So in the next lecture, we are going to study more. We will study about doubly linked list, circular linked list, and we will also do some more questions on GATE. Okay. So this is it for today's lecture. So thank you for watching. Yeah.